Hi everyone, this is a helpful video on the assignment that you have on similar and congruent figures. So we're going to take a look at the assignment and then I'll just provide some helpful examples as you go through this assignment you can refer to. So this IXL assignment is Q1. It's on similar and congruent figures. Okay, so this first question, looking at this first question, we just want to consider the definition of similar and congruent. Okay, um, so in this question, it's asking if these two figures are congruent. So let's take a look at the definition of what congruent means. So when we talk about congruent shapes, we're talking about figures that have the same So these figures are going to have the same shape and the same size. That means the lengths of the sides will be the same. And the measures of the angles are the same. So in other words, the figures might have different orientations. One might be tilted, one might be reflected, but they're going to have the same size and shapes, which means that the lengths are all going to be the same of all of the sides, and then the measures of the angles are going to be the same as well. So let's go back to that question we just looked at. Um, if we're looking at this, we want to look at each of the side lengths and just make sure that they match up. As you can see, this first figure is tilted one way and then the second figure is tilted the other. So you kind of want to match up each of the sides. We could say the LM looks to be the same as VU, MI, it looks like the second figure is reflected, but they're just set up side by side. And then you can also look at all of the angles. It's good with this question, all of the angles appear to be the same. So you can look at these figures and say, okay, the side lengths are the same, the angles are the same size, same shape, which means they are congruent. Now we want to get into talking about similar figures, okay? Looking at similar figures, the definition is going to be slightly similar, but different than what congruent figures are. So let's go back to the other screen. So when we talk about similar figures, we're talking about figures that have the same shape but not always the same size. Okay, so with similar figures, you're going to see the shapes are the same, orientation still might be different, but those side lengths are not going to be equal. Okay, those angle measures might not be equal. And that's where you can decide if they're similar figures by figuring out what the scale factor is of each of those figures. Okay, so let's take a look at an example of this. And I only want to look at this first one. Maybe we'll look at another one to show. So we can see, looking at this first one, we can see that we have two triangles. It appears that we had a pre-image and then it was dilated to get us to the image, but we want to figure out, are they similar for sure? Okay, because this is just going off of what we're looking at. In order to do so, in order to figure out if they're similar, we have to find the scale factor of the side. So I'm going to get a couple different colors. We can say that it looks like, and the good thing is this, the orientations are the same, so we're just going to match these up by the side. So we could say that this green side is going to match to this side. We could say the blue side, I know the is going to match to this side as well. And then we can say that this side will match with this side. Okay, I know the colors are kind of dark, so let me just go ahead and I'll put this one matches with this one, and then we'll do the 2 down here matches with the 2 over here, and then we'll do 3 for this side. Okay, so now we want to set it up. And a good thing about this that we can use is we can say, okay, so this is my original, or you can say your pre-image, and this is my new. So in order to figure out what the scale factor of this, you would take the new size over the original size. Okay, and you just want to check and make sure that they all have the same scale factor. So let's just start with the one that has the 1 dash. Okay, so we know that this is the original, this is the new. So we're going to take this number 26 and we're going to put it over the original, which is 13. And this, we know that fractions are the same thing as division. So we would say 26 divided by 13 will give us a scale factor of 2. Now let's do the side that has the 2 dashes. So we've got the original and the new. And so we're going to take 10, put it over 5. And again, this is a division. Fractions are division, so we would say 10 divided by 5 will give us 2. So we're on a roll here, looking good, looks like they're similar, but let's just check that last one to make sure. So this last side with the 3 dashes, we would say 24 over 12, and 24 divided by 12 will be 2. So we can see that from figuring out the scale factor of each of these sides is the same. Okay, we can assume that the angles would be similar as well, even though this question doesn't show us the angles. A lot of times you would see, you know, this matches with this, and this is a right angle, and then we would say 2 up here. And that would show us these are, the sides are similar, side lengths and the angle measurement. So we would say that, yes, this is an example of similar figures. Okay. I want to look at one more just to kind of show you the difference between finding the similar figures and then finding out if they are what if they're not similar figures? Okay, so you would do the same things. You would do the original and the new, or the pre-image and the image. And we're just going to take that new length and put it over the old length. So in this case, we would say that we have this side. And the good thing about rectangles and squares is you really only have to do the two sides, because this side 15 is the same thing as down here, and 24 is the same as over here, and then same thing here. So we would only have to check the two sides instead of checking all four. Okay, squares are different. You only have to check the one, really, because all the side lengths are the same. So we would say the new is 9, and we would take that over 15. Now this fraction, we can actually take this and we can reduce it a little bit smaller. Okay, think of a number that goes into both 9 and 15. We could divide both by 3. We would say 3 goes into 9 3 times, and then 3 goes into 15 5. So that's our scale factor of that first size. Okay, now we want to take this other number. We want to take the new, which is 12, and place it over 24. And again, in this case, you can reduce this fraction a little bit smaller. The good thing about this is 12 actually divides into 24. So we could just divide both the numerator and the denominator by 12. And we get 12 goes into 12 one time, and then 12 goes into 24 two times. Now, looking at this, we see that the scale factor of the shorter side is 3/5, and then the longer side is 1/2. That means that these side lengths are not similar. These figures are not similar because they do not share a common scale factor between the side lengths. Even though the angles, you can see that all of the angles are right angles. Once we got into checking those measurements of the side lengths, we found that it is not similar. So we would say no. Okay. You'll do that the same thing with the IXL questions. You'll just check those side lengths. As long as you make sure that you, like for instance, we had these numbers from the new, or the image, we put these in the numerator and these numbers in the denominator. As long as you do that, okay, you'll get the same scale factor for all of them. I hope this video helped, and if you have any questions, please reach out and I will be happy to help you further.